Slide 1. This lecture reviews material from section 1.3, and may be skipped if you are already familiar with scatter plots. Slide 2. Science is a systematic study of the structure and behavior of the physical and natural world through observation and experiment. Through this process, patterns and rhythms in nature are discovered. Most natural phenomena are predictable. Mathematics and science work together because mathematics works when it is used to describe nature and the patterns we see. We are confident that if we do the job right, our predictions will be correct. Slide 3. Plots, graphs, and charts are ways to visualize data. There are many kinds of charts that you're probably familiar with from using Excel and other spreadsheet packages. In this lecture, line graphs and scatter plots are discussed. When you see a new graph, study these 4 things. What is plotted on the horizontal axis? What is plotted on the vertical axis? What is the trend of the data, up, down or flat? How fast is it changing? The learning goal for this lecture is to be able to read line plots and scatter plots, and work with functions of distance, velocity, and acceleration. Line graphs are used when one variable, independent, affects another, which is the dependent variable. They are useful for predicting trends. The title of the plot is Inverse Square Law Experiment. The subtitle indicates that this is measured data using a 100-watt light bulb and measuring its brightness at increasing distances from the bulb. 4 questions are first answered before interpreting the plot. What is plotted on the horizontal axis? Read the blue label. The horizontal axis is distance from bulb. The values are given in units of meters. The range of the data are from 0 to 0.2 meters. That's 0 to 20 centimeters. What is plotted on the vertical axis? Read the red label. The vertical axis is brightness at distance. The values are given in watts per square meter. What is the trend of the data, up, down or flat? The farther you are from the bulb, the fainter it appears. How fast is it changing? It changes rapidly closest to the bulb, and slowly farther from the bulb. From the plot we can read individual values to some level of precision. Here we see that at 5 centimeters from the bulb, the brightness is 5,000 watts per square meter. Notice the axis values now on the left are increasing by factors of 10. This is the same data plotted on a logarithmic scale. Also notice that the axis does not need to start at 0. Scatter plots are similar to line graphs. One use of a scatter plot is to show how much one variable is affected by another. The relationship between 2 variables is called their correlation. Sometimes the data points in a scatter plot form distinct groups. These groups are called clusters. Clusters reveal an underlying taxonomy. In the scatter plot to the right we see a correlation or trend between height and weight in humans. Generally, the taller a person is, the heavier they are. We also see clusters. Slide 8. Upon further analysis we find that the clusters tell us about the stage of life of people. The shortest grouping are the newborns. They were visited by a few older sibling children and 2 preteens. Most of the adults were women, and the plots above the main adult clusters are women who are pregnant but haven't yet given birth. Clustering is a useful way to develop a taxonomy or classification system of entities based on some set of observable attributes. In summary, physicists are fascinated by the beauty of the world that includes an mathematic aesthetic. Developing mathematical models of the world is a satisfying and pleasurable activity.